Okay, hi friends. In this video, I will be talking about systems of linear equations. Okay, linear equations. Remember, as I told you in my other video, with one equation, okay, with one equation, you can find only one unknown variable. Okay, if you have two equations, so you can find two unknown variables. Three equations, three unknown variables, and it goes on. Right? Sometimes you have x plus y equals to 4. There is one equation here, one equation, and then two unknown variables. As you can see, what are the unknown variables? X and y. Can we find an exact value for x and y, one specific numerical value for x and y as the answer for this equation with only one equation? No. I would need another equation with the same unknown variable, so I can put them together and find a specific value for x and y. Okay, so let's see here. I would say 3x plus negative y equals 6. Okay, this is my second. I would say 16 is better. Okay, so here, this is equation number 1, equation number 2. I have two equations and I have two unknown variables. Okay, this is called systems of linear equations because it's a system of two equations and it's linear because x plus y equals 4. As you can see from my other videos, it's an equation of a line. Okay, and here we want to find the value for x and y specifically. There are many ways to find the x and y. For today's video, I will try to talk about elimination substitution method. Okay, so there are many methods. Once more, there are many methods. Elimination, substitution. The other one is substitution method. The other one is Cramer. For this specific video, I try to talk about elimination, substitution. So as you can see, this method has got two parts. First part, second part. Okay? So in the first step, we try to eliminate one of the variables so that from the two equation to end up with one equation in terms of one unknown variable. How we can do that? Let me write it down. X plus y equals 4, and then for the second one I can put 3x minus y equals 16. Systems of linear equation, two equation, equation number 1, equation number 2, and we have two unknown variable, x and y. Here, if I add these two equations together, y and negative y will cancel out because they are equal and opposite sign. Okay? So what I'm left with is x plus 3x, which is 4x, equals 4 plus 16, 20. So what I ended up with, one equation in terms of one unknown variable. Can I find the x? Yes. How? I can simply do the opposite operation. Here is multiplication, so I divide it by 4, and remember, once more, whatever you do to the right side, you have to do the same thing to the other side. So I divide both sides by 4, then I end up with x equals to 5. So I found the value for x, right? This is the elimination step. this is I write it down here, elimination step. Okay, so it's step number 1, right? Which, what? I ended up finding one of the unknown variables. The second step is substitution. So I found the value of x. Now I can substitute the value of x in either of these equations and find the value for y. Okay, so let's say I select the first equation, x plus y equal 4, and I substitute x as 5. So x is 5 plus y equals 4. So can I solve this equation? Yes, it's a simple linear one-step. It's a one-step simple linear equation. Okay, so if I want to get rid of the 5, what I should do, I will subtract 5 from both sides, and then I will end up with y equals -1. So as you can see, I eliminated the y in the first step. Then in the second step, which I call it substitution, I substituted my x as 5, and then I ended up with another linear equation in terms of y. Then I solved it and I found the value of y. So as you can see here, my x is 5 and my y is -1. Okay, some of you might ask why I didn't substitute the x value in the second equation. Well, it doesn't matter which equation you use. It's a matter of preference, but let me just substitute it in the second equation, and the answers would be perfectly like the same. So 3x minus y equals 16. So 3 times x, 3 times the x was 5, negative y equals 16. So that would be 15 minus y equals 16. If I want to get rid of the 15, I will add -15 to both sides. So I will end up to negative y is equal to 1. Now, in order to get rid of -1, I'll divide both sides by -1. So I will end up with y equals -1. Okay? And you can see the answers are the same. No matter which equation you use, the answers would be the same. Okay? And I always suggest you, when you solve a system of linear equation, you find the values of x and y, go back to your original equation, substitute the value, and make sure it satisfies the equation. Okay? So let's say x plus y should be 4. So let me check my answer. Okay? So the x is 5, the y is -1. Is it equal to 4? If it's equal to 4, then it shows that I did it correctly. So 5 minus 1 is 4, which is equal to 4. So that means I did it correctly. Right? So if I want to do a recap, in this video, we're talking about systems of linear equation. Remember from my other videos, when you have one equation, you can only find the value for one unknown variable. If you have 2 equations, you could have 2 unknown variables, and you could solve for it and find the values for x and y. If you have 3 equations, you can find the values for 3 unknown variables. Let's say here I have 2 equations, equation number 1, equation number 2. In terms of x and y, okay, 2 unknown variable, 2 equations, 2 unknown variable. Okay, equation number 1, equation number 2. So I will update this one, 2 equations, 2 unknown variables. So I can find the values for x and y from many different methods. It could be elimination substitution, it could be substitution, it could be grammar, or it could be graphical. For this video, for part 1 of this video, we will use the elimination substitution method. Okay, so in this method, it has 2 parts, elimination and then substitution. In part 1, we try to eliminate one of the variables. Okay, which variable should I eliminate? It's up to you. It's a matter of preference. Okay, but try to be smart when choosing the variable. Here, if I want to eliminate the x here, the number in front, it's 1, and the number in front of the other x is 3. So if I add them together, they wouldn't cancel out. So if I want to cancel them out, right, to get rid of the x, this thing should be -3, which means that I have to multiply it by -3. Which I will do, and I will explain in my next video. Okay, or at the I try to solve, well, to be honest, I think it's a better idea for you guys. I try to solve the same equation, but this time I try to eliminate the x. But if I look closely, y and -y can easily be cancel out when added together. So these two cancel out, these two will add it, 4x is equal to 20, right? This is one linear equation in terms of x, so I can find the x. Here it's multiplied by 4, so I divide it by 4 to get my x value, which is 5. This is the elimination step, the first step. I eliminated the y. I found the value for x. Okay, now the next step is substitution. What I'll do, I will substitute x as 5 and then find the value for the other variable. So here I could choose any of these equations and then substitute the x as 5 and find the value for y. So I decided first to substitute the x as 5 in my first equation. X plus y equals 4. So the x is 5. I substitute it here, and then I end up with this equation, which is one simple linear equation. Then I solve it and I find the y, which is -1. Okay, so x is 5, y is -1. Some of you might ask, why didn't you choose the second one? Well, you could, it's up to you, it's a matter of preference. Let me solve it and show it. So let's say some of you might pick up the second equation, okay, and then substitute the x as 5 and then find the value of y. But if you solve it to the end, you will see that no matter which equation you pick, the answers, the final answers should be exactly the same thing. And my advice to you, whenever you solve an equation, go back and check your answers. So here I found the value of x5, y -1. I go back to my original equation, substitute it, and make sure the answer is satisfied. Okay? So, as I promised, now in the rest of this video, I try to solve the same, let me write it down, the same systems of linear equation, but this time with the same method, which is called substitution elimination. But this time I try to eliminate x first. Here the x number in front of the x is 1, here is 3. So So if I want to get rid of the x, the number in front of x should be -3. How could I make it -3? I have to multiply this top row, top equation by -3. And remember, once more, I emphasize, when you are multiplying or adding or subtracting or dividing a number, it should be done to the both side of the equation. So if I multiply this side of equation by -3, this side should also be multiplied by -3. Okay, so my equation turn into -3x, -3y, it's equal to -12. My second equation, it's not changed. I just leave it as it is. Now, as you can see, here I have -3x, here I have +3x. So if I add them together, these two will cancel out. So what I end up with, -3y, -y, if I add them together, -4y. It's equal to -12 plus 16, which is 4. Okay, so what is this? A simple linear equation in terms of y. How can I find the value of y? I divide both sides by -4, right? Remember, by -4. So y equals -1. Is it the same answer as the previous time? Yes. As you can see, y was -1, and here I got exactly the same answer. Okay, so this step was called elimination. Why? Because I eliminated one of the variables, which happens to be the x. What is the next step? Remember, substitution. It's substitution. Now I substitute the value of y in my original equation. Substitution step, okay? And then find the value for the other variable. So let's say x plus y equals 4. Y is -1 equals 4. Can you solve this thing? Yeah. I have to do the opposite. So it's subtracted. I add 1, right? So here I end up with x equals to 5, right? Did I get the same answer as the other time? Yes. X is 5, y is -1. X is 5, y is -1. So as you can see, no matter which variable you want to eliminate first, you have to get the same answers. And once more, whenever you solve an equation, go back, check your answers. Okay? So let's do a few more, systems of linear equation. The next one would be, so I'll try to do, let's say, x -2y, it's equal to 5. Then here I would have -3, I make it 21, -3y plus 2x is equal to 6. Okay, so let's solve this system of linear equation through what method? Elimination and then substitution. So here, let's take a look at our equations. I have equation number 1, equation number 2, two variables. Okay, so what I usually do, I try to rearrange my equation and make sure the variables are aligned underneath one another. what I mean, so I usually start with x. If I start with x in my first equation, I try to align the other x from the second equation underneath, right? So this makes it it makes you to visually, it helps you to solve it, right? And then it avoids further mistakes. So here, what I did, I just rearranged. I didn't do anything, right? So here I have x to x. As my previous example, I will start by, let's say here, I cannot add them together in one step and get rid of one of the variables. So what I should do, maybe I start with multiplying the first equation by -2. So I would have -2x, and then here added to 2x, they will cancel out one another. So I'll add -2x, -2 times -21 plus 42y, it's equal to -10. And here I have 2x minus 3y, it's equal to 6. All right, so what I'll do right now, these two will cancel out. So 42 minus 3, 39y, it's equal to how much? -10 plus 6 is -4. So y is, it is one simple linear equation. Here it's multiplied, so I have to divide both sides by 39 to isolate the y. So the answer would be -4 over 39. As you can see, the x and y could be any real number. It doesn't necessarily mean that x and y should be real nice numbers or whole numbers. It could be fraction, it could be radicals, it could be decimals, it could be whatever. Real numbers, it could be. And the reason why I gave you this specific example was that you could see the numbers doesn't necessarily have to be real nice numbers. I usually leave it as a fraction because if I, unless the question asks you specifically to put like decimal or something. But right now I just leave it as a fraction. I found the value of y, and this is the first step, elimination. So I did the first step, which was elimination. Then I have to proceed with the second step, which is substitution, right? So what I'll do, I substitute the value of y equals this into my original, equation. But remember, I have two equations. One of them is -3 times y. The other one is -21 times y. And as I told you, it's a matter of preference, but you should try to be smart when you're choosing, your equation. Here, I rather go with this one because the number is much smaller, okay? So 2x -3 times y, equals to 6. So let me simplify it a little bit. Negative times negative would be positive. But before I proceed, I just simplify, divided by 3. So it would be plus 4, 13 equals to 6. Now, can you solve this thing? Yes, it's a simple linear equation. So I subtract -4 over 13 from both sides. So it would be 2x equal 6 minus 4 over 13. For those of you who are not familiar to subtract, a fraction from a whole number, what you can do is to do common denominator. So here the common denominator would be 13. 13 times 6, it's 78 minus 4, it's equal to 2x. I just simplify it further, so that would be 74 over 13. Okay, so here 2 is multiplied by x. In order to isolate the x, I divide both sides by 2. So the x would be 74 divided by 13, okay, divided by 2. And how to solve it? 74 divided by 13. This division will turn into multiplication. This one would change into reciprocal, 1 over 2, which then I can simplify these two, 37. So that would be 37 over 13. So I ended up with y equals negative 4 over 39 and x 37 over 13. And remember, my advice to you, always go back, substitute, make sure you have the correct answer. Especially here, you know, because your numbers are not, you know, nice numbers. That really makes sense. So I just go back here. I use the second equation and I substitute the y and x, simplify it, and see if this side will end up to 6, which is the same as the other side, okay? So let me substitute negative 3 times y, okay, plus 2 times x, 37 over 13, okay? So this time I simplify, and then it would be plus negative times negative would turn into positive, 4 over 13 plus 2 times 37, it's 74 over 13, okay? So now I can add these two because both of them have got the same denominator, 13. So 7 plus 74, it's 78 over 13. If I divide 78 by 13, the answer would be 6. And as you can see, 6 equals to 6. So that means the x and y value are correct. Good job, guys. Now, we solve this equation by eliminating the x. Let's do the opposite. This time, let's try to solve the same system of linear equation, but by eliminating the y, okay? So, let me write down the equations once more. X minus 21y equals to 5. And you know, I try, because remember here it wasn't arranged. When I want to copy it here, I just rearrange it. So 2x negative 3y equals to 6. So here I have to multiply this lower equation by negative 7, because then negative 7 times negative 3 would turn into 21, and then they would cancel out one another. So here the first equation, it's not changed. The second one would be negative 14x plus 21y equals to 7 times 6, negative 42. Then what I'll do, I add these two together. These two will cancel out. So negative 13x is equal to x would be 37, right? Negative 37. So here, this is linear equation. In order to isolate the x, I divide both sides by negative 13. Okay, so here I'll end up with x equals negative 37 divided by negative 13, which would be 37 over 13. Let me check my answer. Yes, negative x is 37 over 13. 37 over 13, the same. No matter which variable you decide to eliminate first, the answers would be exactly the same. Okay, so now let's proceed. So the first step was called elimination, right? Elimination step. What I did, I eliminated the y because I eliminated the y, I end up with the x variable. I found the value for x. Now I have to do substitution, right? So what I'll do, I substitute the x as 73/13 and find the value for y. Okay, so I use the second equation. I add the x, 2 times 37/13 minus 3y equals to 6. Let me simplify that a little bit. 74/13 minus 3y equals to 6. So here, I'm glad I am doing this example. Here, what I'll do, I will try to isolate the y, okay? What I will do, I try to add plus 3y to both sides, okay? So I will end up with 74/13. These two will cancel out. So this time the y will be shifted to the other side. And it's perfectly okay. So in the next step, I add both sides. I add -6 to both sides to get rid of this 6 because I want to isolate the y, right? So 70 minus 6, which is 13. 78 minus 74, okay? So that would be 4/13. It's equal to 3y, okay? Now, if I just want to rearrange, 3y is equal to 4/13. How can I isolate the y? I divide both sides by 3. So y equals 4/13 times 1/3, right? So it would be 4/39. And let me check my answers. Just want to make sure everything is correct. Okay, so the y, all right. So here I add -6, 78, sorry, it should be a negative here. I made a mistake. So here that would be -4 and it would be negative, right? Okay, so let me double check the answer. So the y should be -4/39. Let's check the answer. Yes, exactly the same answer. So no matter, once more, which variable you choose to eliminate, the answers would be exactly the same. I hope you enjoy my videos. If you have any comments or any suggestion, please put it in the comment section. Please subscribe and like my videos, and I hope to see you in my other videos. Thank you.